Hi, everyone, and welcome to 2.7, which is the last section of this chapter. So, hooray! Yay! You know, I don't know. So, 2.7 has to do with solving linear inequalities. Okay, so far, you guys have seen inequalities like x less than 2 or greater than or equal to or less than or equal to. So let's talk about what that means. So what does it mean to say x greater than 3? Does that mean that x could be 4 or it could be 5,000 or it could be 700? Basically, it means when you have x greater than 3, any number greater than 3 is a solution. So we're going to get into what does that look like as a picture, okay? So here's a picture. Here's the number line. And so here the book uses parentheses, but I'm going to use an open circle just to make it super clear. But remember that parenthesis and open circle mean the same thing, okay? So if you have, this is when you have greater than or less than, you're going to use these symbols on the number line. And if you have greater than or equal to or less than or equal to, you're going to either use brackets or you're going to use a closed circle. I actually like to use closed circle, but just remember that these are the same thing. Okay, so here the graph of x greater than 3 is all the numbers that are greater than 3. So see, the arrow means it's going on to infinity, positive infinity. Okay, so let's see here. We have the graph of x greater than or equal to 3. It's the same, except that here you would put a closed circle or your book uses a bracket. Okay, now I like closed circle. I feel like it's more obvious. Okay, so that's why I'll say, sometimes I'll even say closed. Okay, so let's say here, let's do a couple of examples, super fun examples. Let me get out of the fun, glittery color here. So let's say I want to graph x less than or equal to 1. Okay, so I'm trying to graph all the numbers that are less than or equal to 1. So here's one. This is really all you need to do. Because it has the equals, that equals to, that means it's going to be closed. And then because it's everything less than, that means it's everything to the left, okay? Everything that's smaller than 1, okay? So like 0, -1, and da-da-da, okay? What about B, where it says x strictly less than 5? So the best way to do this here, so if you have a 5, it doesn't include 5. So notice that we have what's called a strict inequality. So you would do an open circle and then to the left, okay? Everything smaller than 5, but not including 5, okay? So, and then let's do another one, x greater than -1. So you see kind of where we're going with this. The point of interest is -1, but because it's strictly greater than, there's no line here. You would do open circle or parenthesis and then go to the right because everything greater is to the right, okay? All right. So let's do super fun more examples. Okay, so what about x less than 1, x greater than 2, x less than or equal to -1, sorry, x greater than 2, or x less than 3. So let's go through them. Just choose a different color for fun, You know what fun is. Okay, so so let's say we're doing a number line here, and what's the point that we are caring about? We care about -1, and here it says x less than or equal to, so that means closed circle, or in your book it would say bracket, okay, and everything that's to the left. So if you notice something, if you have the variable, the inequality, and then the number, notice that the end that you shade matches, kind of like it points to the same direction, okay? Your shading is going to match this. That's only if you have it in the form x, the inequality, and then the number. So let's say here, for instance, you have 2. You want to graph all the numbers that are greater than 2, but not including 2 because there's no equal sign. So you notice that there's no line underneath this greater than symbol. So we do circle, and then you see how it points to the right. We're pointing to the right, okay? Pretty cool, right? Not too bad. Okay, so here, x less than 3, strictly less than. So it's an open circle and to the left. I'm sure you said it out loud, and if you did, Kudos. Okay, so that's how these graphs look. Not too bad, yeah? Not too bad, not too bad. Okay, let's continue. So one more thing we're going to talk about is interval notation, okay? So it's just another way to describe what's happening. So here we have x greater than 3, yeah? So we see here it's an open circle and going to the right. Now, if you want to use it during using interval notation, we're saying, okay, we want all the numbers that go from 3. So you just would look at this and you would say, okay, nothing, 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 nothing from this going from left to right. Here at 3, don't include it because it's open. So that's 3 comma, and then there's graph, there's graph, there's graph, all the way to positive infinity, right? So we just write infinity like that. And you can never, so parenthesis means open, right? So it makes sense that infinity is never contained with a bracket. So anytime you write infinity or negative infinity, there's always going to be a parenthesis in interval notation. That's interval notation. Okay, so this interval notation is just another way of describing the same set of numbers that this picture is, okay? All right, so, okay, so let's do another example, okay? So let's say here we have x less than or equal to 1. So the graph, here's the graph, matches, right? Less than, equal to, so it would be closed, right? So it's closed and to the left. Okay, now remember, so interval notation, remember this arrow to the left means, hey, I'm going all the way out to negative infinity. It doesn't say it, but that's what it's actually telling you, okay? So if I was to go from left to right and say, okay, where's the graph? Okay, there's graph here at negative infinity, so I'm going to go ahead and start off negative infinity, comma, and then I keep going, there's graph, there's graph, there's graph, there's graph, and it goes up to 1 and it stops at 1, so you would close it with a bracket. So it would be, interval notation would be negative infinity, comma, and then stop at 1. Okay, that's another way to represent all these numbers, okay? This interval. All right, so let's go ahead and just restate this. Okay, so if you have x greater than a, strictly greater, see how it does, this right here doesn't have a, there's no a little line underneath the inequality, so it would be open circle or parenthesis, and then shade to the right, and then the interval would be at some number a, so it would be parenthesis, the number, comma, and then to positive infinity, and then close parenthesis, okay? So it would be both parentheses. So this one, x greater than or equal to a, you can think of it as, you can either do a bracket or you can do that closed circle, and then it shades all the way to the right. And then when you write it in interval notation, you start with the bracket because you're including that point, and then you go number, comma, all the way to infinity, okay? Then when you do x less than a, so it would be everything to the left of that number a, and then it would have an open circle or would have a parenthesis. So the graph, the interval notation to match that graph would be negative infinity, comma, then it would stop here at that number, but then you would have a parenthesis because that means open, that means do not include it. So that here you have x less than or equal to a. So that, what does that graph look like? Here at A, you're going to close it and then go all the way to the left because you're talking about all the numbers that are less than that value A all the way up to negative infinity, yeah? So when you write your interval notation, you think to yourself, okay, I'm on the left side, it goes all the way to negative infinity, so I do a comma, parenthesis, negative infinity, comma, then you say, okay, well, where does it stop? It stops at A, or 3 or 5,000, whatever the actual specific problem is, and then you bracket it. Okay, so why do you do this square, this bracket? Because you're including a. So the sooner that you make that connection, the easier your life will be, okay? So let's do some super fun examples. So let's say here I have x greater than 2, strictly greater than. Okay, so what does that look like on the number line? So 2, then it's open at 2, and it's greater than, so it's shade to the right. Okay, interval notation, go down. Is there any graph on the left side? No, 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 no. At 2, I'm doing parenthesis, comma, and it goes all the way to the right. So that's infinity, positive, okay? So for this next one, we have x less than or equal to negative 1.5. So you draw a number line. At negative 1.5, it's closed. So you can do dark circle, and then it's less than, so it's to the left. Okay? And then when you do interval notation, okay, interval notation, it's going to start at negative infinity, comma, go all the way to 1.5, negative, and then bracket. Okay? Then the last one we're going to do here, we have x greater than or equal to 3/4. So the nice thing is it doesn't matter. You don't have to write any of the other numbers, but you just have to know that they're there. Okay, so at 3/4 here, close it, and it's greater than, so it's to the right. Okay, and then when you're doing interval notation, okay, at 3/4 is where the action starts happening, comma, all the way to positive infinity. Okay, all right. So let's do another example. Okay, so graph on the number line and write in interval notation. So here we have x strictly greater than 2. So there's your number line. Here's your info, 2. It's open circle. It's strictly greater than, so it's all the way to the right. Then interval notation, okay, where does the graph begin? It starts at 2, but it's open. It goes all the way to the right, which is infinity, and that's the end of that interval, okay? So that's that one. How about here, x less than or equal to negative 1.5? Did we just do these? Wait a minute. I feel like we just did these. Okay, yeah, we just did. Sorry, my bad. Let's continue. Okay, so for this next part, let's review some properties of equality. Okay, so remember, when you have an equation, if you have an equation that is true, if you divide both sides by that number, the equation still holds true. And that is the same for multiplication and division, okay? So that when you're dealing with equations, if you divide one side by something, you have to divide the entire other side by the same thing, and your equation is preserved, the equality is preserved, okay? It's still a true statement. But for inequalities, it changes just a tad, okay? So you can still divide and multiply both sides by it, but the thing is, when the only thing that changes is that if you multiply or divide by a negative number, the inequality reverses, okay? That's what all this means, okay? So if you're multiplying, so in this case, this first one says, if you're dividing by a positive, the inequality stays the same. I mean, multiplying by a positive, right? And dividing by a positive. If you're, if it's greater than and you're multiplying or dividing by a positive, the inequality stays the same. But if it's negative, if you're multiplying or dividing by a negative, notice that it changes, okay? So why is that true? So I'll give you an example. So let's say we all know that 1 is less than 2, yeah? We all know that, okay? There's no doubt about that. What if I multiply both sides by negative 1? Let's just go ahead and do that. We can do that. So that means that negative 1 here on the left side of the inequality, and 2 times negative 1 is negative 2. Now, question for you is, does this equality, should this stay the same? Is negative 1 less than negative 2? Those of you with who've ever had a negative bank account know that that's not true. This is false now, right? And the only way that I can make it true is if I flip the inequality. Okay, so here, negative 1 is greater than negative 2. So if you multiply or divide, because you know those two are related, by a negative number for inequalities, you reverse the inequality or you flip it. Flip it. Okay. So let's do some. Okay, so let's say here 7y less than 42. Okay, and we're trying to solve inequalities now. So of course we treat them like as if it was an equation, but then we apply that special rule if it so happens. Okay, so 7y, we know what to do. We're going to divide both sides by 7. So y is still less than 6. Okay, because 42 divided by 7 is 6 today. So how do we do that on the number line? We have a 6. That does not include 6, so that's open circle and then to the left. If you guys adopt the textbook, then your graph would be parenthesis and to the left, which is fine too. I don't care. Okay, and then interval notation. Okay, so interval notation asks the question, hey, where is their graph? Okay, so going from left to right. So left to right, okay? So I'm looking at this and I go, okay, here's where my graph begins. That's negative infinity, and I never bracket negative infinity because that's technically not a number. It's kind of like an area, right? And then I have more graph, I have more graph, I have more graph. It keeps going and it stops at 6, but it does not include 6. So I have to end it with a parenthesis. So that's interval notation. I know I keep saying the same thing over and over again, but that's because we kind of retain only like a quarter of what's told to us. I don't know. I think for me, it's much less. So sometimes I'll just repeat the same thing like 6 times, and I'm thinking at least hopefully one of those 6 times will stick, yeah? Okay, let's do another one. Let's solve the inequality. Negative 10a greater than or equal to 50. Okay, so if this was an equation, we would tell ourselves, okay, let's divide by the coefficient of a. Hello, yeah. And the same applies here. We still do the same thing, except that what? Ding, 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 ding. We're doing the rule where we're dividing by negative. You know, you have to think to yourself, oh, wait, you know, I'm dividing by negative. So what does that mean? I need to flip the inequality. Okay? This is the first, if you can believe it. Okay, so I'm dividing both sides by negative 10. That's going to cancel on the left-hand side, so a. But now, instead of writing greater than or equal to, I'm going to write less than or equal to. 50 divided by negative 10 is negative 5 today. So then from there, it's not too bad, right? So here's my negative 5. Shade that, and then it's less than. So you shade to the left. Okay? And then interval notation, remember, okay, fine, the graph begins at negative infinity, and it goes on and on and on, and it stops at negative 5, but we're including it, so I need to write a bracket. So this is including, this is like saying in math symbols, hey, I'm including negative 5, you know? All right. So sometimes when you're solving, the variable is on the right side. So you can rewrite the inequality to get the variable to the left. So it's easier to graph. So this is like easy to graph. Okay, remember, because the graph matches the inequality, yeah? So x greater than a has the same meaning as a less than x. You can think of it as if Xavier is taller than Alex, then Alex is shorter than Xavier, or you know, if 1 is less than 2, then 2 is greater than 1. And we kind of already know that. It's like common sense. But in math, a lot of things that are common sense, we're translating to symbols. Okay, so once you understand that these symbols are just common sense, you are going to be good to go. So let's go ahead and solve this inequality. And we're going to use this property, okay? So if this was an equation, I'm going to multiply by the reciprocal, right, of the coefficient of u to get rid of it. So I'm going to multiply both sides by 5/4. Now, some of us, I know I'm not saying it's you, but some of us, because we are a large class, and there's always at least like, I want to say like there's always a percentage of people that ask this question. So I'm just going to go ahead and ask it. Some of us might think, oh, look, there's a negative here, so I need to flip it. No, that's a no. Because the thing is, it's only flip when you're actually multiplying or dividing by a negative. Okay, so in this case, we're multiplying by 5/4, but that's positive, so we leave the inequality as is for now, okay? So 4 goes into 20 5 times. 5 times a negative 5 is negative 25 on the left. Bring this down, and that's less than u, right? So if negative 25 is less than u, if I can rewrite this as u greater than negative 25. And then so now the same people or different people might say, hey, wait a second. I thought you said, you know, because I'm multiplying by a positive, I don't flip it. So why am I flipping it? Well, let me tell you, and let me explain this to you really, really well. And you need to make sure you pay attention to this, okay? Super focused. The only reason that I flipped it here is because I flipped everything, okay? I moved the u over, I flipped the inequality, and then I took the negative 25 and I put it on the right-hand side. That's why. And that kind of a flip, that flip is allowable all the time, okay? But you have to flip everything, okay? All right, so now that I have it this way, it's easy to graph. So here's negative 25. It's a strict inequality. I do not include negative 25, and I'm going to the right because I want all the values greater than that. Okay, so now I have my graph, check. Now I want an interval notation. Is there graph here? No graph. The graph begins at negative 25 but does not include it, so that's a parenthesis, comma. And I'm continuing all the way to infinity, and I end it with a parenthesis because we do not bracket infinity ever. All right, cool. So hopefully that makes sense. Let's do a couple more examples. So let's say here we have 24 less than or equal to 3/8 m. So multiply both sides by 8/3 times 8/3. Cancel, cancel. Here we have 3 goes into 24 8 times. 8 times 8 is 64, less than or equal to m. But rewriting that, m is greater than or equal to 64. Again, this is easier to graph. So here's my graph, 64. I'm including that value by, having a dark circle or a bracket, and then I'm shading to the right. Okay, so now interval notation, boom, 64, comma, all the way to infinity. Okay, so let's do the next one, times 3/4 times 3/4. My goal is to get the variable by itself. So here, 4 goes into 24 6 times, but it's negative. 3 times a negative 6 is negative 18 today, and that's less than n. Okay, and now I flip everything. So n is greater than negative 18 because I want to graph it. Okay, so then this is my negative 18 here. I'm not including it. Okay, so open circle and then to the right. Okay, so then interval notation, negative 18, comma, infinity. Okay. All right, let's do this next one. I have k over negative 12 less than or equal to 15. So what's the reciprocal of k being divided by negative 12? It's 1 over negative 12. So to cancel this out, and I multiply both sides by negative 12, okay? So that's going to cancel this here. You're going to get k. But what happened? Oh, ding, 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 ding. I'm multiplying by a negative, right? So what does that mean? What does that mean I need to do? I need to flip, right? Flip. That says flip. F-L-I-P. Okay, so then that means I need to flip this inequality here. So greater than or equal to. And then 15 times 12, or 15 times negative 12, excuse me. 15 times negative 12 is going to be negative 180. Okay, so now it's time to graph. K is greater than or equal to negative 180, so shade to the right. Interval notation, graph begins here, going from left to right. I'm including it, so I bracket, and it goes all the way to the right up to infinity. Okay, close parenthesis. Now, sometimes you're going to have to do a little bit more work until you get to that point where you can solve for m. So like, see here, you have the variable on both sides. The same rules apply. We're going to subtract both sides by 9m. Okay, that cancels out here. 4m minus 9m is negative 5m today, less than or equal to, then you bring down that 17. Now, solving for m, divide both sides by negative 5. Again, I'm dividing by negative 5. What does that mean? I'm going to flip the inequality, boom, and that's going to be 17 fifths negative, right? So graphing, boom, negative 17 over 5. I'm including it. I'm shading to the right, okay, because notice the match, okay. Then interval notation, nothing. Okay, the shading begins at negative 17 over 5. It includes it, so it's a bracket, comma, and the shading continues all the way to positive infinity, okay. And then let's do this one here. We have 8p plus. Let's distribute this 3. We have 8p plus 3p minus 36 greater than 7p minus 28. So our goal here is to get the variable on the left and everything else on the right. So simplify here. This becomes 11p minus 36 greater than 7p minus 28. So minus 7p to both sides. And this becomes 4p, bring down the minus 36, greater than negative 28, okay? Simplifying again, I'm going to move, quote unquote, I'm going to add 36 to both sides, okay? So 4p is going to be greater than what? Negative 28 plus 36. So that's going to be 8 positive. Okay, so 4p is greater than 8. We're almost there. Divide both sides by 4. I get p greater than 2. So we know what that is. Here's the 2. It's open circle to the right. Okay, and then interval notation, even easier, right? Open circle or open parenthesis, comma, 2 goes all the way to the right to infinity. Okay, all right, so now just when you're doing word problems, okay, so just remember, so a couple of things. Translate to inequality and solve. Remember that in words, the greater than looks like this is greater than. Words that will tell you more than, larger than, or exceeds. Greater than or equal to is at least this much, no less than, or is the minimum. Here, some keywords, less than, smaller than, fewer than, lower than. And then for less than or equal to, the symbol, the words would be is less than or equal to, is at most. X is at most 8, is no more than, is the maximum, okay? So 12 times C is no more than 96. So here we have is no more than. Let's look at our little charty chart. Oh, okay, that means that 12C is not going to be any more than 96. So the 96 is the maximum, right, that it's going to be. So we just divide, right, solve it. 96 divided by 12 is 8 today, right? It's funny because in the classroom setting, people correct me, so now I just have to trust, you know. Okay, so C, here's 8, less than or equal to 8. Let's graph that, okay, to the left, matching. Great. Interval notation, negative infinity is where the graph, the shading begins, and it continues up to 8, but then it includes 8, so I bracket it, and that's it. Okay, let's do a couple more. 9 times Z is no less than 135. So even if you have your, you can have this little chart with you, it might help. So no less than, right? So you would have that here. Greater than or equal to is what you use. So 9 times Z is no less than 135. Oh, this is Z right here. 135. Divide by 9, divide by 9. Z greater than or equal to, and then 135 divided by 9 is 15. So then here's your line, 15, you know, closed circle, shaded in to the right, right? This arrow matches this kind of pointing thing. They're both pointing in the same direction. And then internal notation starts at 15, continues all the way to infinity, okay? 20 times y, okay, is at most, and as at most is this one here, at most means that it's less than or equal to, you use that symbol. Okay, so less than or equal to 100, so 20, right, we're going to divide both sides by 20. Y is less than or equal to 5, so we know the graph for that. That's 5 here, shaded in, we're including it, and then we're going to the left, and then the interval notation starts at negative infinity is where the shading begins, and it stops at 5 and includes 5. Okay? All right. So that's it for 2.7, and that's the end of chapter 2. Congratulations. You did it. Yay. That's supposed to be a heart, I think, meaning that you love math. Okay, so 431 to 503 odd. Good luck, and I will see you guys on the next video.